Good afternoon, everybody. My name is Veda Shembekar from the editorial department of EM and A&D India, and I will be your host for the day. It gives me great pleasure to welcome you all to today's webinar on how demand for recycled PET is growing globally and the right way to integrate it into your packing, conducted by Husky Technologies. Your media partners today, Publish Industry India, is a 16-year-old publication and media and branding company based in Pune, parent to two magazines, A&D, which is Automation and Digitization India, and Efficient Manufacturing, which is EM. A&D covers automation and digitization in the manufacturing and industrial processes, while EM covers discrete manufacturing developments that directly impact multiple industries. Through A&D India and EM, we have been associated with multiple national industry associations as well as international partners like Ringier Trade Media. We have been reaching Southeast Asian clientele like China, Malaysia, and Taiwan. Regarding our organizers today, as the largest brand name supplier of injection molding equipment and services to the plastic industry, Husky Technologies comprises engineers, designers, innovators, material and software specialists, and most importantly, problem solvers. Team Husky includes more than 4,300 dedicated people worldwide, functioning in over 140 countries over the world. In the webinar today, we will be addressing some points like the definition of recycled PET and the growing categories of its applications, global and regional trends driving the increasing adoption of recycled PET in packaging, rPET innovations in Asia and around the world in packaging categories, the challenges associated with recycled PET and the right way to integrate it into your packaging, achieving a completely sustainable package with recycled PET, lightweight, tethered closures, and finally, new Husky developments to further support the industry in adopting more recycled PET bottles. Before we begin today's webinar, please note that you can send your questions for the speakers in the chat box mentioned. The speakers will be taking up these questions one by one at the end of their presentations. Beginning with the speakers for the day, let's begin with the first speaker. Our first speaker for the day joined Husky in 2006 as a part of the engineering team in Canada and has since held several progressive technical and management roles within the rigid packaging business in Canada, Singapore, China, Thailand, and now the United Arab Emirates as well. Mr. Philip holds a bachelor's degree from the University of Waterloo, Canada, in mechanical engineering. Our first speaker will be Mr. Philip Parubets, General Manager of Business Development, Husky Technologies. Our second speaker, Mr. Venkatesh Srinivasan, supports customers on a new application development and package optimization needs, serving the India and Southeast Asia regions. He has 23 years of experience in the PET industry in areas of PET resin manufacturing, recycling, and PET preform manufacturing. At Husky, over the years, he has held diverse roles in service, sales, key account management, and most recently, PET packaging development for various applications. Mr. Venkatesh holds an MTech from BITS Pilani in digital manufacturing, an MBA in marketing management, and a bachelor's degree in engineering in electronics and instrumentation. Our second speaker, Mr. Venkatesh Srinivasan, is the business advisor, Husky Injection Molding Systems, Husky Technologies. Our third speaker, Mr. Oliveira, holds the position of Business Manager PET Systems for Husky Injection Molding Systems. He joined Husky in 2007 and since that time has held a variety of positions throughout the organization. He holds a degree in material engineering from the Universidade do Porto, Portugal. Please welcome Mr. Pedro Oliveira, Business Manager PET Systems, Husky Technologies.
Thank you, Veda, for the introduction for Husky and for myself, Venkatesh, and I. As Veda mentioned, my name is Philip Rubitz, and I'm the Business Development Manager for Husky. And thank you for attending this training called How Demand for Recycled PET is Growing Globally and the Right Way to Integrate it into Your Packaging. Let us begin. So let me add a little bit more about our company to what Veda has said. We have been in the business for over 70 years. And 40 of those years, we have been involved in the PET packaging industry. In fact, we are one of the pioneers of the technology when it started back in the 1970s. And recycled PET has become and is becoming a greater and bigger portion of our business as time goes on. So before we start, I think it will be instructive to talk about what is recycled PET, or as we call it, rPET sometimes. So let us talk about some definitions, some facts, and get the big picture. And here we start with the PET bales or the PET bags, which is the feedstock that goes to the recycler. If it's a formal collection, it's usually organized in PET bales. If it's informal collection, usually in PET bags. And this feedstock goes to the sorting and washing step of the recycling operation. Usually this equipment is packaged together. Usually if you go to OEM and procure sorting and washing machines, they're usually one integrated system. The input of this system is going to be the PET bales and PET bags, of course, and the output of this sorting and washing step is going to be that washed clear and light blue flake. And what it does, it takes those PET bales and PET bags, all those bottles with all the other contaminants in there, and it removes all the contaminants, the metals, the caps, the glass, everything else that is not a PET bottle. It removes it and it washes it and ultimately becomes the washed clear and light blue flake. And how it does that, there's some mechanical separation. We have some magnetic eddy currents, which remove the magnetic objects. We have some air jets to remove all the light material. Sometimes incorporates a vision inspection system to remove some colored bottles. At one point, there's a grinding step that takes the PET bottles and grinds them into flake, which allows for another mechanical separation step. Sometimes includes a zigzag sorter where the heavy PET flakes fall to the bottom and the lighter materials floats up into the air. And then after those flakes enter the washing step where they're vigorously washed, so the outside surface of the flakes are very cleaned very well. And also there's a float sink process usually where the PET flakes are put into a tank. It sinks to the bottom, and all the lighter materials such as the HDPE caps, etc., float to the top. So it's another mechanical separation. And then usually in that step, you have that vigorous washing. So there's a number of mechanical and washing steps in between. Different proprietary technologies would include different steps here, but the outcome is going to be the washed clear light blue flake. Many recyclers, this is their operations. This is what they do. They have the sorting washing step. Their output is this type of flake, and there's many applications available or applicable for this type of material, and that is their business. The question is, if you want to use recycled PET for food contact applications, for food grade applications, so to speak, we need to have another step. And this is the decontamination step. And the reason why we need this is because even though we wash the outside of the flake, there's still volatile contaminants in the middle of the flake. And that does not come out in the sorting and washing step. So we have the decontamination step. And this is usually a separate piece of equipment. And there's a number of OEMs around the world that specialize in this type of technology. There's many versions of this technology that's available in the market, but all of them have two specific ingredients that they need to include. Number one is heat, and the other one is time. And the combination of both is what allows for those volatile contaminants within the flake to be able to precipitate out. And it usually includes some other technologies. Typically, there's usually an extruder there to melt the flake into liquid, and then after that it goes through a filter which removes some solid contaminants, and then there's usually a pelletizer there that makes it into pellets. However, in some other decontamination units, we don't do the pelletizing. The output is still food grade flake. So the input to the decontamination is going to be the wash clear light blue flake, and the output is going to be food grade pellet or flake, whether it has a pelletizer or not. Usually in that decontamination step, sometimes there's optional crystallinity boost and there's IV boost, which is sometimes also very important for PET bottles. So we have two outputs here. It can be a pellet or it can be a flake for food grade. And if we are looking particular at the pellet, which today is the most common form of a food grade rPET today, flake, there's probably less and less of that we see in the market today. But when it comes to pellet, we see that there are two shapes that is available in the industry. You can have rPET pellet, which is in cylindrical or cubical form, or you can have rPET pellet, which is in spherical form. And by virtue of the fact that most of the pelletizing in the decontamination unit is done underwater, usually the melt will form into sphericals. And this is okay. Both the spheres or the cylindrical chips can run in the injection molding process, but it needs to be noted that spherical pellets are more difficult to melt because it's more difficult to generate that shear energy, and therefore more consideration, more care needs to be taken in terms of scoping out your injection unit system, your screw, and managing your process. And afterwards, the final step here is that these pellets, whether it's spherical or whether it is cylindrical, is fed to the injection molding machine, produces the preform, and ultimately makes the bottle. So here we see that recycled PET contributes to a circular economy, make the preforms, makes the bottle, consumes the bottle, goes back to the recycler, and the process continues again. Let's take a look at how rPET fits into the big picture. So of course, we have virgin PET resin, and oftentimes we see rPET resin being combined with virgin resin, and there are different percentages available for that. You can start as low as 25% or even less in some cases. We see in the market 50%, and a lot of cases we're seeing 100%. I think most brand owners are opting for the 100% rPET option because they're getting feedback from their marketing teams that from a sustainability point of view, consumers resonate best with the 100% rPET. But for many practical reasons, maybe not possible to do 100% rPET. They are stuck with 30% or 50% because of the availability of rPET pellet in the market, or perhaps the price is very, very high. And sometimes we also see colorant is sometimes added to the mix. And the reason for this is that rPET pellet is often producing some yellowing or brownish color, depending on the quality of the resin. It could be a very strong color, or it could be a rather mild color. So there's an option to add some kind of toner or to add some type of color to mask that to that color from the rPET resin. The challenge here is that the colorant acts like a lubricant itself. So when you combine the fact that you have a lubricant colorant and you got the spherical pellet, the combination of both even makes melting even more challenging. So again, more consideration in terms of scoping out your injection unit and taking a look at your process to make sure it is optimized for recycled PET. When we talk about virgin PET, we need to understand that there's two building blocks that make virgin PET. One is ethylene glycol, MEG, and the other one is PTA. 70% for the first one, 30% for the second one. And both of these building blocks can be made either from non-renewable resources or renewable resources. Regardless of which one you use, the output is going to be virgin PET, which is 100% recyclable and support the circular economy. The question just becomes, where is the raw materials coming from, whether it's renewable or non-renewable? So when you see renewable resource, we often call this like a bio source. And some of you might have heard of plant bottle being used by bottlers and others in the consumer good market. And all it's telling you here is that the virgin PET resin is made from biosourced resources, for example, like corn or other organic compounds. But at the end of the day, it is 100% recyclable. When you go out to secure rPET pellet or flake from the market, oftentimes if you're sourcing it from a quality resin supplier, they're going to provide you a specification sheet, and that will include the resin IV, the resin crystallinity, the acetaldehyde level, the size of the chips, and the color, and et cetera, et cetera. Husky, we too have a specification for the recommended resin specifications coming into our injection molding machines, and here too we include items such as recommended IV, recommended crystallinity, the size, and etc. Beyond PET, we also have other materials such as PETG, PLA, polypropylene. These type of materials have also been injected using our injection molding machines to produce preforms and bottles. And each of these type of materials might have some benefits in their own way, but it needs to be understood that these types of materials are considered as contaminants in the PET recycling stream. So care needs to be taken to segregate those type of bottles out from the PET recycling stream, and they need to be managed and in a separate stream. So here we talked before about a summary of recycled PET, and it could be understood that recycled PET actually fits into the broader story of sustainability. And here I'm talking about four major pillars of sustainability. The first one is recycling the circular economy, which recycled PET is an integral part. The second part is reduce greenhouse gases. And here I'm talking about reducing your carbon footprint. Then we have reduce your raw material consumption. And finally, zero waste, whether it is on land or whether it is in the sea. However, it could be argued that recycled PET or the recycling in itself can form the bedrock, the foundation of all of these other initiatives. It is the enabler for all of them. For example, if we combine recycled PET in your packaging and package lightweighting, you're going to be able to achieve, you're going to reduce the raw material consumption in your packaging. You're going to reduce the carbon footprint of your packaging. You can also reduce the waste reduce the waste. And finally, the lightweighting will help contribute to reduce the cost of your packaging, therefore sponsor the use of rPET, which is oftentimes more expensive. So we're seeing many bottlers, when they look at sustainability for their packaging, recycled PET itself is the core of their efforts, because they see the value of recycled PET in enabling all of the other sustainability goals that they have. And they combine it with lightweighting, because lightweighting allows them to reduce the cost of the package to enable the inclusion of recycled PET into their packaging. Husky also is involved in a number of other sustainability innovations in packaging. For example, we have a portfolio of tethered closures. We are working with labelless bottles, which also support recycling. And we're also developing in the future PET closures, which will help simplify recycling and potentially increase PET bottle bale yields. Now let's talk about some of the trends that we see with regard to recycled PET. And probably the overarching, the biggest trend that we see is the really enormous demand growth for recycled PET globally or all around the world. And this is coming from the fact that we have many consumers around the world are opting for recycled PET packaging. They're interested in purchasing consumer packaged goods, which are packaged in recycled PET bottles. Secondly, because we're also seeing brand owners are taking the initiative themselves, and not just brands, but everybody, all the stakeholders in the industry, whether it is the resin producers, whether it is the converters, they are also interested in promoting circularity and recycling and including recycled PET into their packaging. And finally, we are seeing that from a legislative point of view, there's more and more legislation being enacted to support circular economy and inclusion of recycled PET in the packaging. So the combination, the confluence of all of these factors is causing demand for recycled PET to really grow. And at this point, it's really outstripping the supply of recycled PET in the market. And this is great news in terms of the fact that the demand is very strong here, but there's an opportunity here to substantially increase the supply of recycled PET to match the demand. But until then, it means that the price for recycled PET is rather high in the market right now. Sometimes availability could be a challenge, and sometimes the quality of recycled PET can be compromised because everyone is looking for recycled PET, but there's simply not supply out there in the market. So let us talk a little bit about these trends a little bit further. So this is a map showing where recycled PET is being used in packaging as a percentage. So we see that most of the world, the percentage of rPET used in PET packaging is rather quite low. There's some variance from region to region. For example, in Western Europe, it's around 17%, but most of the rest of the world, we're talking about single digits of rPET being used in the packaging. So to promote the circular economy and the inclusion of rPET, we're seeing a lot of legislation being enacted around the world to force recycling and to force the inclusion of rPET. So most of these type of legislation manifesting in two ways. Number one is increasing the recycling rate, making sure the bottles are being disposed of or being recycled in the proper way. That's number one. And number two, to make sure that every new bottle that being produced includes recycled material. So these are the two types of factors that we're seeing being included in much of the legislation around the world, and it's having a positive effect. Everywhere where this type of legislation is being passed, we're seeing more recycling. The recycling rate is improving, and we're also seeing the percentage of recycled PET being used in the bottle is also increasing. And because of this, we expect more and more jurisdictions in the future to institute legislation to promote recycling and recycled content in the packaging. And the brand owners and the rest of the stakeholders in the industry are not waiting for legislation. They're moving ahead, even further ahead than oftentimes what legislation requires. Here we see a number of key brand owners, and I'm not listing here a number of the converters and also a number of the resin producers and other stakeholders in the industry. They all have their own sustainability objectives, very bold objectives. For example, we have 25% recycled content in packaging, 50%, even up to 100% recycled PET to be included into the packaging by various years for all of these brand owners. So again here, great news, but with these bold goals, demand for recycled PET is growing very fast, but supply is the opportunity that we need to look at to improve. Now, let us jump into the various examples of recycled PET that we see being deployed all around the world, across all different types of packaging, across all different types of categories, whether it is soft drinks, whether it is liquid dairy, or whether it is home and personal care, or even alcohol. We're seeing recycled PET being incorporated in PET packaging. Let us explore some examples. We start the story with bottled water because this is where recycled PET was first deployed in the soft drink category. The first three examples here are Evian, Danone, and Suntory. And all three of these examples, we're seeing that they're opting for labelless bottle. And here the logo and the artwork is created by embossing. So in the blow mold, we are putting the features there, and then it comes out as an effect, as an embossing effect on the bottle. So we see that for all three of these cases. Evian was one of the earlier adopters of this type of technology, using 100% rPET, a very sustainable solution. Danone did a similar type of bottle for 1.5 liter, a rather larger bottle, and they deployed this type of bottle in a number of countries around the world: Mexico, Argentina, Spain, and Indonesia. Here again, also 100% recycled PET. In Japan, we see a lot of different brand owners deploying labelless bottles here. In Suntory's case, they have an interesting innovation here, where some of the information that would normally be included in the embossing is now printed in a carton clip that's clipped to the neck of the bottle. And this could include information about the company, information about the water, whatever other information they would desire. They print it on the carton clip, and they clip it onto the bottle. And what's great about this is that it's very easy to remove the bottle. It's very easy to, especially in the recycling step, this carton comes off quite easily. So it's a very sustainable solution. Here we have Nestle. They are deploying recycled PET across their entire family of bottled water, ranging from 1.5 liters down to 330 ml. They've also employed some other sustainability features. And here I'm talking about tethered closures. They also have a transparent wraparound label. And the benefit of that is that the ink is minimized just to the area around the logo. And they also minimize the amount of glue that's used. So it's also a very sustainable bottle, and the minimization of the ink and the minimization of the glue helps to promote the recycling step. So during that sorting and washing step, by removing the secondary, tertiary materials as much as possible, it makes the recycling easier. And finally, we have an interesting example with iServer in Canada. Here, they have a fully closed loop system here. They do the sorting, washing, decontamination, the entire recycling operation in-house. They make the preforms completely in-house, and they blow and fill in-house. They, in fact, even have cooperation with the local municipalities in Ontario to help collect all the bottles to make sure they have enough feedstock coming into their recycling operations. And we see more and more operations around the world who are interested in this type of setup, where they want to bring in-house the recycling operations together with their preforms and together with their the bottling operations. The next category is carbonate. So after bottled water, we see carbonates as the next soft drink category to deploy recycled PET. Coca-Cola in Australia was one of the earlier adopters of recycled PET into carbonated soft drinks. In fact, they have made very significant commitments. Up to 70% of all of their bottles should incorporate recycled PET. And this includes bottled water, includes soft drinks, and even includes, for example, aseptically filled juices and teas, and even nitro hot filled products. So across all of their portfolio, across all different categories, they have included recycled PET. Also, Coca-Cola and other stakeholders in the industry, for example, Pepsi, Clearway, Impact, they have all come together to set up together the largest recycling operation in Australia. And this type of model, this type of cooperation, we're seeing more of that around the world, where bottlers and other stakeholders in the industry at all levels are coming together to support building recycling capacity, which is needed, and also to support sustainability and marketing and advertising to encourage people to start to continue recycling to a greater extent. And on the right, we have an example recently launched in India, which is the 100% recycled PET. So we have a proliferation of CSD bottles around the world today, which are using 100% recycled PET. And even going beyond bottled water and CSD, we start seeing that we have rPET used in juices and sports and teas and other types of sensitive products. So we have an example here on the left, which is Innocent Juice, one of the earlier adopters of rPET in juice out of the United Kingdom. They have 50% rPET. As advertised here, we have 15% plant-based, bio-based PET, and they're working on the rest. Naked Juice is another brand which is deploying 100% rPET. So all these examples here between Innocent and Naked Juice, these are aseptically filled, or it is a fresh filled juice. And finally, you see to the right here from PepsiCo, they're committed to have 100% recycled PET across their entire product portfolio, similar to Coca-Cola here and Coca-Cola in Australia. And here we see Tropicana Juice, and also we see here ready-to-drink tea for Lipton, going to be deployed with 100% recycled PET. And finally, going beyond the soft drink category, here is liquid dairy. We're also seeing a lot of innovation packaging in this category. And the first step, we saw a lot of interest to move from HDPE to PET. And as you see here, underlined here, even bottlers recognize that moving from HDPE bottle to the more environmentally friendly PET bottle is the more sustainable solution. A big reason for this is because the recycling rate for PET is much higher, and also it is easier to recycle PET afterwards back to the bottle. So brand owners are recognizing, and we see a lot of movement in the liquid dairy segment to move over from HDPE to PET. And there is a number of other benefits to PET, but one of the prime benefits is the sustainability factor. They've also included a number of other innovations here in this bottle. Number one, they have a full sleeve that covers the entire bottle, which means they don't need glue to keep the label attached to the bottle. They just have the bottle gripping on, the sleeve gripping onto the bottle. But they also serrated that sleeve such that you can easily tear that sleeve off the bottle, and this makes the recycling step a lot easier. So there's another innovation that's included. And they also lightweight the bottle from 38 millimeters down to 32 millimeters for some additional lightweighting here. So here we see a full transformation from a relatively less environmentally friendly HDPE bottle to a much more friendly PET bottle, incorporating some of the other innovations in sustainability that FrieslandCampina has deployed. And even in the wine and spirit segment, recently we're seeing a lot of innovation with regard to recycled PET. On the left, we see Diego, an American brand, deploying 100% recycled PET for their whiskey bottles. Originally, they were in glass. They converted to PET to simplify distribution of their products. And then from PET, they converted to 100% recycled PET. And on the right, we're also seeing, even in the wine segment, even in the premium wine segment, we're seeing 100% recycled PET being deployed there. Looking beyond beverages, we're seeing 100% recycled PET being deployed even in food and sauce segment. For example, on the left, we have Stokes. For their family of products, they have 100% recycled PET. On the right, for Hellmann's mayonnaise, they have deployed 100% recycled PET across their portfolio of mayonnaise products as well. And even taking one step further back, even beyond the food and beverage categories, we're seeing rPET being deployed in home and personal care products. So here we're seeing a lot of transformation being made in the packaging for these type of products. The first transformation we're seeing is that they're making moves from other types of plastic materials towards PET, because they also recognize that PET is more sustainable. And here I'm talking about moving over from flexible packaging, moving over from HDPE, polypropylene, other types of plastic materials towards PET. Sometimes it is a opaque PET, but in many cases they're moving it to a colored clear PET, which is more more friendly for the recycling. At least they won't be filtered out in the recycling process. And then finally, they are sometimes even making a transparent bottle, a clear bottle, but they're putting the color inside the product itself to make another step in the sustainability. Let me call out one example here, Ecover on the left. They have an interesting innovation here. They added ridges to the shoulder of the bottle. And the purpose of that is because they recognize that the recycled PET will have some color in there. So they realize, why not add the ridges, which will highlight that color a little bit more. So we take what is originally a challenge and turn it into an opportunity. So they're using that color there to highlight the features of that ridge. So it really, they're taking what is a challenge and turning into an opportunity. So this concludes my discussion, my survey of different types of examples of 100% recycled PET around the world across all different types of consumer packaged good categories, from bottled water all the way to home and personal care. Now I'd like to introduce my colleague, Venkatesh, who will talk about the trends that we're seeing in India in terms of recycled PET legislation, in terms of capacity being built there, and also in terms of some of the recent launches that we're seeing in India with regard to food-grade recycled PET. Thank you, Venkatesh. You can take it from here.
Thank you, Phil. Thanks for this opportunity. Today, I'll be bridging the gap between introduction of rPET, sustainability, and the global examples, which Phil talked about, to what Husky can bring in as a solution for you from our expert Pedro after my few slides, wherein I will be specifically talking about relevance of rPET with respect to India and what are the recent changes which has happened onto that. Post my few slides will be Pedro, who's an expert of Husky and into rPET, and he will give you more insight on how you can move into rPET with Husky being the successful partner for you. Here, India is a global leader in PET packaging, applying to the broadest range of applications with innovative and industry-leading designs. I will talk about some of the recent developments in the PET recycling, which we believe marks the beginning of a significant evolution in the Indian PET packaging industry. Where are we today? If you look at the global consumption of plastic, India is at number 3. Looking specifically at the PET, there is a growth which has been happening for the last few years in a fast pace, and the CAGR till 2030 is also at 6.12, one of the highest. So there is going to be a lot of PET which will be processed. If you look at the recyclability of PET in India, we are one of the highest in the world at 90% of PET bottles produced in India are recycled into either fiber or moving on to other applications. Meaning India is going to have an enormous feedstock for PET recycling with the growth which is happening with respect to consumption. India is getting serious about recycling and the circular economy, and this is expected to deepen going forward. There are 2 new developments important for PET recycling in the last couple of years. The first one being FSSAI approval for recycled plastic for food contact applications, opening the door for recycled PET to be applied to whole new category of consumer packaged goods in the Indian market. The other important aspect, as you can see here, is India's legislators enacting EPR guidelines to strengthen the circular economy and support the recycling industry. The 2 important outcomes of these EPR guidelines for PET recycling are as follows. there are targets now set for the recycling rates, and there are targets now set for minimum recycled content in PET packaging. As you can see on the box on the right end, the recycling rate for PET is set at 50% by 2026 and 80% by 2028. The recycled content to be incorporated is set with a target of 30% by 2026 and 40% by 2027. Progress towards these targets will support the recycling industry in India. Already, we are seeing significant investments in bottle-to-bottle PET recycling capability and capacity being added into India. 4 approved recyclers are currently identified by FSSAI, and we expect this list to dramatically grow to support the anticipated high demand for food-grade rPET in India. This slide talks about, it is not about legislation, but there are various stakeholders spanning the entire PET value stream are also proactively coming together to promote the circular economy and PET recycling, such as the PACE Foundation, where Husky is part of it. And you can see all the big names and the brands of India coming together towards building a better economy with respect to PET, recyclability, and a circular economy. With these new developments, we are seeing new recycled PET products already coming into the market in India. Phil talked about the carbonates, where Pepsi has introduced onto that, wherein on the right, you see that water by Coca-Cola is recently introduced with 100% rPET as well. We believe with the consumption growth in PET and our proven capability of recycling, that we'll be the global leader with respect to production and deployment of food-grade recycled PET industry-wide. It has already begun in India. With that, I wanted to hand it over to our expert, Pedro, who will talk about technology and how Husky can support you make your business successful with the need of tomorrow.
Thank you very much, Venkatesh. Great introduction. Great update about India. I think we can add to all the list that you mentioned about the facts on rPET in India. I would predict that by 2028, 2030, India is also going to be the country with the fast acceleration rate from almost no PET in bottles, no rPET in bottles, to a huge percentage in bottle. Because in fact, the growth and the way things are moving in India is in fact remarkable. I know that there is a significant amount of decontamination units, plants that will be installed within the next 2 to 5 years. So a very, very interesting country to look for in the next coming years. So with that being said, I think it's important to note one question following what Phil mentioned before, right at the beginning, that today the big challenge when incorporating more rPET into the package is really the fact that we have to deal with something completely new in the PET industry, is to deal with the fact that the material is a variable now into the injection molding equation. Until now, we were always talking about different technologies, different generations, the newest generation of machines and molds, the application, the processing, the processing of that application into that machine. Today, we have to consider that even if we keep all that stable, and we will have a material that is gonna be a change or going to be a variable into this equation. So it's very important to understand with this. The main message is there's no such thing as rPET. There's rPETs. So we need to consider the material as a variable. What is the Husky approach is really to understand the complete circularity of PET from bale, as you can see in this slide, from bale to bottle. So we understanding each and every step, and how does this contribute to the overall quality of the package, starting by how does the first stages, if it is the bale quality, where does it come, the bottles come from what season, from what country, that will change the type of bottles we have in a bale. And then the different mechanical recycling technologies, sorting technologies, washing, as Phil was mentioning in his first slide, that will affect the quality of or the specific quality of a certain rPET. We are testing different levels of different rPETs and correlating those characteristics with the performance on the preform and also on the bottle. Here is an example I wanted to give you. So we offer today what we call the rPET as a service. Part of that is resin grading and also preform analysis. So we could correlate a resin with a preform in prototyping, for example. And you can see in this slide a correlation between solid contaminants. Solid contaminants are a result of the collection and washing technology. So we know that, for example, in regions where the collection is done through a deposit return system, the quantity of solid contaminants is lower. For example, in Germany, when compared to the US, for example, we know that solid contaminants in the resin is lower, and that will have an effect on the A's that you can have in the preforms. So we can know what could be the influence of certain characteristics in the resin within to the preform, and we can also know how does a certain rPET from that specific batch, but how a certain rPET will behave in comparison to the best in class, or in comparison with the average that we see in a certain region. So this is something that we can offer our customers today as we speak. So before taking a material, 10 tons of material, putting it into your dryer and testing it in a real mold and a real machine, feel free to come to us and we will be happy to support. How does this variability that I talked for the last minutes about impact the technology? The first point I wanted to make very clear is that our systems are rPET proven. So we've been running rPET in Husky systems since over 2 decades. Standard systems with percentages of rPET or rPET content up to 100%. This being said, what I mentioned before, that there is no such thing as rPET, there's rPETs. So there's rPET virgin-like quality, and there's also rPETs that are of a poorer quality. For several reasons, we could spend a long time discussing about this. So what we've done is that we incorporated a certain amount of technologies that are optional. Some of them are also, or the more important, are embedded in our systems since years. But we have upgraded and have some options that we can suggest to you to mitigate the risk to deal with those worst quality rPETs. So you see it in this slide is an extensive list that it passes from having the appropriate dryer. We know that resin drying, we know that rPET resin is more sensitive to drying. So most of the rPET producers suggest longer times at the lower temperatures in the hopper. So for that, we have incorporated that solution into our systems. Also incorporating metal separator, oil condensers, gravimetric blender to mix different percentage of rPET. And then what I believe is the most important characteristic here, we will be mixing most of the times different resins. Phil mentioned at the beginning the fact that we have pellets that are cylindrical and other pellets that are round. And we want to make sure that each and every cavity of those 144 cavities or 96 or 128 cavities have the same quality of melt. And for that, we need to make sure that there is a proper mixing. There's no segregation in the hopper. There's proper mixing in the extruder. And then we have the best quality melt delivery systems to bring each and every cavity the same melt at the same constant quality. So this is for me the most important point that I would like to highlight at this moment. Then, of course, system level recipe, specific rPET HMI screen, something we're going to bring to the market very soon. And then our self-cleaning mold, because also I will have a slide, the importance of the self-cleaning mold with increased use of rPET is really there. Once we have some rPETs that do create a lot of dust in the vents, and you need to make sure that you have a solution that really prevents you from producing bad quality parts, and that's where the self-cleaning mold comes into the game. And then I will have a slide also on the downstream inspection. The injection molding machine is not a filter. So if you have, for example, a lot of solid contaminants into the resin, they will pass through the system, and we need to make sure that we have a good quality downstream inspection to detect that, and also to detect color variations, for example, and this is what I'm going to spend a bit of time also talking about. And then together with that, all our soft skills that go from Advantage Plus Elite, our training capabilities with the Husky Academy, and also factory planning and optimization. So one slide dedicated to the hot runner. Very important. I think the quality of Husky hot runners is well known in the market. Very important to mention also here the proactive dust reduction by addressing the dust root causes and not trying to take out the dust already created in the hot runner. This is very important, and also the fact that we have a controlled and very good hot runner balance. In this slide, you see normally we talk about hot runner balance to ensure that you can achieve the tighter tolerances and therefore have subsequential significant resin savings. Here, the approach is slightly different. We have to think that you have an income variability on the resin, mainly IV, for example. You have an IV variation in the input of the material, and your hot runner is going to be able to accommodate that variation with IV and keeping your preform within the required dimensional specifications. So this and also keeping avoiding degradation, cavity to cavity variation. So all that is much more important when we're talking about a variability or a variable input, which is the case by definition with recycled PET. The self-cleaning mold, here I would like to give a concrete example. Think about you're running with a certain preform with one specific rPET, let's say 50% of rPET, and you have to change that rPET, or there is different batches. And you change the rPET, and you are used to clean your vents every 15 million cycles, but now you have to you keep with that rule. You stop the mold, you clean the vents. But this recycled PET that you bought from a different supplier creates much more dust because they do not eliminate the volatiles as they should in the previous process. So there is a lot of dust creation in the vents, but and you will not know it because you used to clean it at a certain regularity. So which means that you will be producing trucks and trucks and trucks of preforms with unfilled top sealing surface, for example, right? Or with defects on the support ledge. So all these are quality issues that you could mitigate by having a self-cleaning mold. This together with the fact that you extend the maintenance, the periodic maintenance of a mold, or giving you a significant increase in productivity. I have a quick video to show you how the self-cleaning mold works. You can see here the mold is in normal cycle. You see, it's a normal cycle of operation. Then you have programmed the self-cleaning mold cycle, and then you will see now this is how it's going to work. You can also do it by clicking in a button on the HMI of the machine, but in this case, it's self-programmed. You can program it when you want it. What happens is that the mold slightly opens, and you have like a volunteer-induced flash on the mold. And what's happened is that the plastic is gonna adhere to this dust that is in the vents and remove it by exiting the preforms in the next cycle, which you will see now. So preforms are rejected, and there we go. So this is how the self-cleaning mold works. The next point where I mentioned also before is about the downstream monitoring. Is not 100% inspection, is monitoring of the preforms. If you detect, for example, that you start having more solid contaminants, you can see what is the problem with the overall processing. And also something that we will bring to the market also quite soon is the capability of detecting color variation and closed loop correction of that color variation, knowing that color variation is one of the main issues we have our customers telling us about when they run rPET. And yes, so I talked a lot about hardware until now, but very important, Husky Complete, the industry-only complete connected end-to-end production solution, the hardware parts, but also everything related to training, soft skills, factory planning. I have a couple of slides on that moving forward. An example of factory planning, a customer here in Europe that wanted to produce for a major world brand 100% rPET preforms. And we were the partner of choice by providing the right solution. At that point, we were able to completely convert a building that was used for other purposes to the production of rPET and the production of preforms. And then being able to do this as a complete end-to-end single contact project management, engineered for full traceability, which is a request for this specific plant. And I think it's going to be a request more and more moving forward that we have full traceability of the material. This done completely hand in hand with the customer, and supporting them until the plant was completely up and running, and they could fly independently. Our Advantage Plus Elite, so the most responsive connected service and support. So this is we call you. This provides you increased availability, performance, and quality, eliminates the cost of emergencies, reduce material and energy usage, and also increase plant knowledge and capability. And I would like to finish with a sneak peek of our recycled melt to preform system, which is the world's most sustainable system. Quick explanation about this. So when normally you produce rPET pellets, let's remember the first slide from Phil. You go from washed non-food grade flakes, the result of a sorting and washing line, and you put it into a melt decontamination and IV boost equipment, and you produce rPET pellets. So what are we doing here? And as the name says it, we are going from the melt to preform. So we're not pelletizing. At the end of that decontamination unit, we're not pelletizing. We're not cooling down, storing the pellets, and then re-drying it and remelting it. No, we jump completely from that decontaminated IIV melt from the melt decontamination unit, being it an NGR or an EREMA or a Starlinger, and we move it directly into our injection molding machine. So this gives significant energy savings, 30% only on the fact that we don't dry and re-extrude the material. So you can imagine that the savings, if we consider cooling down, pelletizing, transport of the resin, so everything together makes it much higher, the energy savings that you have here. And also, of course, with energy savings comes carbon footprint reduction, which I believe is going to be the thematic of discussion after the thematic that we have at hand today, that is the recycling content. So what is an RMTP? Is an HPP5 machine, is a proven system, is based on a proven platform, is exactly an HPP5 machine with the same capabilities, the same options, the same performance. It's good to know that we sold over 600 machines, 600 of those machines, HPP5 machines. So it's a completely proven, validated, top of the line injection molding machine. With a modification, instead of having an injection screw, we have, as you can see in the picture, we have a melt transfer pipe and then a universal melt interface that is also based in proven technology. We have a system that we launched in 2010, which was called the rPET RF, that had a dual shooting pot, was to run with flakes. So this dual shooting pot, it was used to convert the continuous flow that is inherent to a twin screw and convert it into a batch to batch flow. Here is the same thing. We also receive a continuous flow and we convert it to a batch to batch with using this validated, proven technology, no news there. So we dedicated all our development effort into how do we connect with the upstream decontamination unit, and we are working with different partners that you can see here in this slide. We have sold 3 systems up to date. We have 1 system running with an IREMA line in Japan. We have 2 other systems in order, 1 with NGR and 1 with IREMA. And we also have other opportunities now close to be finalized with also different partners. And this concludes my presentation. It was a pleasure. Thank you very much, and feel free to reach out if you have any follow-up questions. Thank you.